In the next question, we are given 50 ml of 0.1 molar sodium cyanide solution and is titled with 0.1 molar strong acid HCl solution. How the pH of the solution changes, that is the variation of pH of the solution with volume of HCl being added will be, that is with the addition of HCl to sodium cyanide solution, pH will be varying. That variation of pH is plotted against the volume of HCl is added. So what will be the appropriate curve for the plot? That is the question. So in this particular case, we are given NaCN solution. It is the salt of strong base weak acid. So the solution is initially basic in nature as per salt hydrolysis. So this basic solution of concentration 0.1 molar is being titrated against HCl solution, which is a strong acid whose concentration is also 0.1 molar, and initially this is taken 50 ml. Now as strong acid is added to this salt, what will happen? So the reaction takes place as the salt solution is basic, and since strong acid being added, neutralization starts taking place to give NaCl neutral solution sodium chloride, as it is a salt of strong acid strong base, and a weak acid HCN is formed as a result of the reaction. So it's a titration now. So initially some pH is there for this basic solution which will be more than 7 because it is a basic solution. So pH will be more than 7. And since we are adding HCl to this, the pH will slowly become less. Strong acid being added, the salt solution reacts with it, liberating weak acid. So the base is getting neutralized with this acid. So thus, with the addition of HCl, gradually the pH of the solution decreases. So if we see the curve C and D, here is also increasing. So therefore, the option C and D are straight away ruled out. Why? This sodium cyanide solution is a salt of strong acid, weak base, therefore basic in nature, pH will be little more than 7. And now we are adding acid and this base is reacting with the acid, it's getting neutralized. Therefore the basic strength should decrease. So pH should decrease. Here in these two graphs, what are we finding? Straight away they are increasing. Here it is increasing. Here it is increasing. So therefore these are two which are ruled out. And now say as we go on adding HCl drop by drop and a stage is reached, say by the time when we add around 25 ml of 0.1 molar HCl. 25 ml of 0.1, 2.5 millimoles we are adding strong acid. So originally we have taken 50 ml of 0.1 molar, 5 millimoles we have taken. So by the time we add around 25 ml of 0.1 molar HCl to this, 2.5 millimoles of H plus being added, the 5 millimoles out of which 2.5 millimoles will react away, leaving around 2.5 millimoles of this. From the stoichiometry form the reaction, we also see that for every 1 millimole of HCl being added, 1 millimole of NaCN will react to give 1 millimole of weak acid. So from the 2.5 moles when added, 2.5 millimoles will react to give 2.5 millimoles of the salt NaCN will be left over by that time, and as a result of the reaction 2.5 millimoles of HCN will be formed. So at the end of the reaction here, that is after the addition of 25 ml of 0.1 molar HCl, we find that 2.5 millimoles of salt of strong base and weak acid and 2.5 millimoles of weak acid is left over. So weak acid along with salt of weak acid with strong base is left over. What do you understand from this? So when we observe the result after the addition of 25 ml of 0.1 molar HCl, what is that we are left over with is 2.5 millimoles of HCN weak acid is formed and 2.5 millimoles of what? Salt NaCN. But what is this salt NaCN? It is the salt of weak acid and strong base. In other words, an acidic buffer is formed. So during the course of the reaction, the solution is becoming acidic buffer, and with further addition of HCl, what will happen? Since it's a buffer, even when we add relatively large amount of strong acid, the change in pH will be very less. And as more and more amount of HCl is still added, then buffer property is slowly lost. Whole amount of NaCN must react with HCl added to give neutral solution NaCl and hydrogen cyanide. And finally, when this is completely neutralized, a weak acid will be left over. So buffer property is lost and a weak acid property will be resulted, and thereby the pH will again gradually decreases. So in the beginning of addition of HCl, pH will decrease relatively large, and when it becomes a buffer, it almost remains same, change will be very less, then again decreases slowly. So therefore, during the entire titration, there should be a decrease. Only thing is, in the beginning, relatively more decrease will be there in pH. At the stage of buffer formation and buffer, less decrease in pH will be there. Again, small decrease will be there. So let us observe the four curves given. So this C and D are already ruled out, and if we observe this curve B, it is continuously decreasing throughout the titration process. Whereas in this, it is decreasing almost in this part, it is remaining constant and again decreasing and then steadily remaining. So therefore, the curve A looks to be more appropriate than B is drastically decreasing. It's not showing any part of the reaction resulting in the buffer formation. So we are understanding that during the titration, a stage will be reached where buffer is formed, and then buffer slowly loses its property, resulting in the formation of weak acid.